Hello and welcome to lesson 3.2 Radian measure and angles on the Cartesian plane. So today what we're going to take a look at is how to actually use any measurement or angle on the Cartesian plane and use it within relation to radian measure. Well, first of all, let's say we do have an angle theta right here. As you can see, theta is an angle, and each of these are sine, cosine, tan, cosecant, secant, and cotangent. Well, please always realize that you must have a function in order for you to write an angle after it. If you do not happen to have both of these, then if you just write sine, let's say, equals y over r, you're actually incorrect, because sine is a function of the angle. So let's say we have an angle theta. That's primary angle in standard position somewhere on the Cartesian plane. Now, for my own purposes, I'm going to draw this in my third quadrant, let's say. So this angle theta right here relates to my height right here, which we commonly call y. It also represents the distance from the y-axis, which we call x, and also the length right here, r, can be calculated by using the square root of x squared plus y squared. So using the Pythagorean theorem and these values of x and y, depending on their values being positive or negative, you can actually calculate sine theta, cosine theta, tan theta, cosecant theta, secant theta, or cotangent theta. Also remember that in grade 11 you reviewed something called the 45-45 triangle and the 30-60 triangle. Well, because we know that angles in degrees can be also measured in angles in radians, you can change these easily into a pi over 4 triangle and a pi over 6, pi over 3 triangle. Also realize that you can take any of these triangles and you can multiply them by any constant that you wish and make a different size triangle. So for instance, another option to write the 45-45 triangle, or even the, my apologies, let's write this triangle, the pi over 4 triangle, you can multiply everything by the square root of 2. So if you multiply the lengths by square root of 2, the angles stay the same. This just becomes square root of 2, this side becomes square root of 2, and this distance turns out to be 2. Some people like to change these by multiplying or dividing by a constant. Okay, so some other things to remember. This circle drawn off to the right is what's called the unit circle because it has a radius of 1. Also remember our special triangles and the cast rule. Cast rule states that in this quadrant, cosine is the only thing that's positive. In this quadrant, all are positive. In this quadrant, only sine is positive. And in this quadrant, only tangent is positive. And also realize that you can also represent things by what are called related acute triangles or related acute angles. So let's say we again do have a angle theta in standard position. That's a principal angle. Well, it relates to another angle, which is always represented as positive, and I'm going to call alpha right here. This is my related acute angle. It's always positive in between the values of 0 and 90, whereas this one is usually called the principal. You may also call it here as the primary angle. Primary angles or principal angles don't necessarily have to be positive, but most of them are positive. If they're ever negative, they're traveling in a in a clockwise direction instead of a counterclockwise direction. And the related acute angle triangles are always giving you positive values, whereas the primary principal angle might give you negatives. So using the CAS rule, you can help yourself in understanding those concepts. So let's determine the exact values of each of the following. To do this, you don't necessarily need a calculator. You can use a calculator. Some calculators will give you the exact value automatically. I'd like you to show me how you get these values. So let's first start out by drawing where pi over 4 is. Remember, pi is over here, so pi over 4, a quarter of pi if you wish, is just here. This little angle right here is pi over 4. Well, what we can do is we could draw a right angle triangle with this, and that right angle triangle matches to this special triangle. Well, because of this, I can actually work out the exact value of this. Well, sine represents, according to SOHCAHTOA, is given by the opposite, which in this case is the value 1, and over the hypotenuse, which is the value of square root of 2. Now, some textbooks, some teachers, some professors prefer you actually to write it so that the denominator does not have a square root. Personally, I don't mind, but what you can do is you can multiply this by the square root of 2 over the square root of 2 so that you can cancel the square root of 2 in the denominator. It becomes 2, and the numerator just is square root of 2. Okay, so let's try the next one. Again, pi is over here. This is 7/6 of pi, which is just a little bit bigger than pi. So this angle, I'm going to list as 7 pi over 6. Well, because this angle right here, the related acute angle, is only pi over 6 units away from pi, we can actually come up with some more parts of this triangle. So I know this length would be 1, this length would be square root 3, and this length would be 2. Now, because of where it's actually located, this is actually negative root 3 and negative 1. So tangent, again, is opposite over adjacent. The opposite here is negative 1. The adjacent is negative root 3. First, I'm going to cancel out the negatives. Next, I'm going to get rid of the square root in the denominator. And I get an exact value of root 3 over 3. Okay, so let's try some more complicated examples. So if you know what to do with these ones, I suggest that you pause the video and try it out on your own. Okay, so the angle 3 pi over 4. Pi over 4 is right here. Gives us a related acute angle of pi over 4. Okay, so cosecant is the reciprocal of sine. So sine of 3 pi over 4. So 1 over. Well, this is 1 over. Sine of 3 pi over 4. Sine is opposite, which is 1. Hypotenuse is root 2, so the reciprocal of 1 over root 2 is just square root 2. Okay, let's try this last one. This one's a little bit trickier. Well, again, this is where pi is. 3/2 of pi, or 3 pi over 2, actually is right here. It's right on this axis. Well, this gives us a little issue here. Okay? Well, first of all, cotangent is a reciprocal of tangent. So 1 over tan of 3 pi over 2. What we can do is we can take any point along this axis right here, in this direction I mean. So if I want, I can choose this point as 0, -1. Those are my x and y values, and also it would give me an r value of also 1, so my radius would be 1. Well, I can use this information to actually figure out what this value is. So tangent is opposite over adjacent, or if you wish, y over x. So -1 over 0. The reciprocal of this just turns out to be 0. Be careful, because this value could be listed as undefined, means that then this entire expression would be undefined. But if you're looking for the reciprocal, it's actually the values of x over y. So you can use the definition that you were given on the very first page. Okay, so let's try another one. So if cosine theta equals -5 over 13, where theta is between the values of 0 and 2 pi, whenever it states this means you're looking for the value in radians. Don't change it to degrees and then back into radians. It doesn't always translate properly. So we want to evaluate the value of theta to the nearest hundredth. Nearest hundredth means to 2 decimal places. Okay, so what I'm going to do this, I'm going to rewrite this. And to get rid of a cosine on the opposite side of the function, you take a cosine inverse. This is the inverse function of this. Now, some people prefer to use positive 5 over 13 to find the related acute angle. I'm fine with finding cosine inverse of -5 over 13. Sometimes they'll actually give you the exact answer that you need. So I'm going to calculate this, and I find out it's about 1.97. Well then, where is 1.97? Maybe it'll help us out. Well, again, this is the value of pi, or 3.14. 1.97 would just be somewhere in this quadrant right here. And this would give you the value of theta. Well, according to their cast rule, this is definitely one of the locations where sine is positive or cosine is negative. Now, in order to figure out where the other value is, or other values that fit in this frame of reference, the 0 to 2 pi just means in a full rotation, positive, only one positive full rotation, meaning we need to find another one. And you can see cosine is also negative in this quadrant right here. These two terminal arms should be approximately the same size and within the same angle reference. So, first of all, I need to find out this related acute angle. And this is where, if you wanted to find the cosine inverse of positive 5 over 13, it could also work. Well, to find out that value of alpha, please realize alpha is pi units from the value of 1.97. So you just have to subtract it. Using the exact value on your calculator, do not change the answer. You find alpha is approximately 1.18 when rounded properly. So that means this angle right here is also alpha, or approximately 1.18. So now we can find the other value, or another possible value of theta that would fit this expression. So I'm going to say or theta could equal, now to figure out the other one, you start at pi and you're going alpha units away, so 1.18 approximately. I'm going to take my exact value of 1.18 on my calculator and add pi, and I get another answer of about 4.32. So be careful with your rounding here. Make sure you're using exact values on your calculator. Okay, let's try one last problem. Stating an equivalent expression in terms of the related acute angle for cosine of 4 pi over 3. Well, first of all, we have to figure out where 4 pi over 3 is. So again, this is where pi is. 4 pi over 3 is just past pi. 4 pi over 3. Okay. Well, it also wants us to find it in terms of its related acute angle. So, a related acute angle here is pi over 3. Because pi over 3 plus pi is 4 pi over 3. Okay. So according to my cast rule, the only thing positive here in this quadrant is tangent. So, what that means this means cosine of 4 pi over 3 is a negative value. Well, if I had drawn according to this and the related acute angle, pi over 3 right over here, you'll see that value is positive. So in order for cosine 4 pi over 3 to be equal expression, it has to be a negative. So that means you're going to have to put a negative on that value. So cosine of 4 pi over 3 is going to equal negative cosine of pi over 3. We'll see other related acute expressions a little later. There are many different possible ones, but this is one possible one, especially if you're using the same function. If you're using a different function, there are actually other options. And thus concludes this lesson.